Hello everyone, this is Emil Naruto. Welcome to my channel. So today in this video, I'm gonna talk about unsupervised learning. In the earlier video, I have already explained about what is meant by a supervised learning. In this video, I'll give you in this video, I'll give you a brief explanation about this unsupervised learning along with all the categories involved in it. So what is meant by an unsupervised learning? For example, just imagine we have this data. Okay, here we have some data points. Here I'm not mentioning what is this particular data point name. In the sense, I'm not labeling anything. So all my data is unlabeled. Okay. For example, this is my training data. This is my training data. I'm saying my training data is unlabeled. In the sense, it doesn't have any label. Okay. So if my training data is unlabeled, then on the test data itself, what can I predict usually? If it is having some label, then I can usually predict something with a particular label. But here it doesn't have any labels here. In the sense, it is purely unlabeled. My training data is always unlabeled. In the sense, actually, what is happening is my model is trying to learn without a teacher, without the supervision of someone. My actual model is trying to learn. Okay. If you have any labels for your training data, then there is some kind of supervision involved in it. But here, my training data doesn't have any labeled data. In the sense, my model is actually learning without any supervision. Okay. So that comes under the unsupervised learning. So here now I want to explain the most important unsupervised learning algorithms. So here now most important unsupervised learning algorithms. So what are these? The first one is clustering. Okay. This is a kind of technique. Okay. Clustering is a kind of technique, and it's a type of unsupervised learning algorithm. Inside this clustering, we have a few algorithms related to clustering, that is k-means and db-scan, also hierarchical clustering, cluster analysis. In short, we can always call it as HCA. Okay. And also we have another technique called anomaly detection and novelty detection. So this is a kind of unsupervised learning technique. In this category, we always have few algorithms, that is one class SVM. SVM in the sense support vector machines. I have already made a clear video on that. Just have a look. I'll be providing in the I button here. And isolation forest. Isolation forest is a kind of algorithm. Okay. Here I want to mention some important point. I want to have some important point here, like some neural network architectures can also be unsupervised. Okay. Some neural networks architectures can also become unsupervised. Example, auto encoders, restricted Boltzmann machines. So these can also be supervised. So these can also be supervised. These can also be supervised, for example, such as in deep learning, in the sense in deep belief networks. And unsupervised pre-training. Don't worry, this is just a brief explanation. So I'll be talking about in a very deeper details in the coming videos. Okay, just for now, just remember this: neural network architectures can also become unsupervised. Okay, these are the examples: autoencoders, restrictors. These are actual neural network architectures, but these can be used as unsupervised learning. Okay, and these can neural networks architecture can also become supervised. How? Example, in deep belief networks and unsupervised pre-training, this can also be used as supervised. Okay, so this is the thing. And we also have the third category, that is visualization and dimensionality reduction. So this is the third category. So this is the third category. So in this third category, third technique, we also have few of the algorithms, that is whenever we say dimensionality reduction, we always know that this would be the first principal component analysis, PCA, and the other one is kernel PCA. The third one is locally linear embedding. That is, in short, we can always call it as LLE. The fourth one is T distributed stochastic neighbor embedding. In short, we can always call it as TSNE. The so this is it. After that, we also have some other kind of technique, nothing but fourth one, association rule learning. In this, we have few of the categories like a priori, and we also have eclat. So these are all the these are all the techniques. I mean, these are all the categories of unsupervised learning. So we have four uh, unsupervised learning techniques. Out of these are all the specific algorithms that are involved in each of the categories of unsupervised learning. So now I want to have some example here. So for example, what is meant by this unsupervised learning techniques? How it will be usually look like? Okay. For example, this is my x-axis and this is my y-axis, and here I have some groups. In these groups, I have few of the records, data points. Likewise, okay. So what is this particular graph? What do we call it as? We call it as clustering. So this is the example for clustering. This is the example for clustering. Okay. What are these data points actually? These are these these data points are the visitors in Netflix. Imagine this. Okay. Sorry. And I'm saying 40% of them 40% of them watch thriller, 20% of them watch comedy, and again 40% of them watch romantic. So by clustering all these data points, I got to know that 40% of those visitors usually watch thrillers genre, and 20% of those visitors usually watch comedy genre, and 40% of those visitors usually watch romantic genre. So likewise, we have got to know after performing clustering. Here, we need not to tell our model for which a visitor belongs to. It automatically finds that without any of the human intervention. Okay. If I say without any intervention, there comes the topic of unsupervised learning. Without intervention or without supervision, all these comes under the crux of unsupervised learning. Okay, so that's all for this video. I'll see you in the next video. Take care. Jai Hind.